All right, welcome to the notes on Chapter 4, Section 1. This stuff should go pretty quick and be pretty easy because we've started to do some of these things, but we're just gonna get better at it now. Okay. I told you guys in class some graph paper might be useful. You can sketch them when you're doing your homework and stuff, but either get graph paper or go to the class webpage and get some graph paper there. On the class webpage, if you scroll down to the bottom right here, 12 grids, graph paper. If you open that, you'll get that right there. That's graph paper for you guys to use whenever you want. All right, so let's take a look at slope-intercept form. So we've talked about this already. We have some experience with it, so that's a good thing. Y equals mx plus b, where m is the slope and b is the y-intercept, and this is called slope-intercept form. Okay, the variables m and b are called the parameters of the equation. Changing either value changes the equation. So real simple, right here we have 6. That would be the y-intercept. 2 would be the slope. No problem really. If you look at a graph, this is not the graph of that line. This is just another example. B would be this point right here, the y-intercept, and M would determine the steepness of the line. All right, so first, let's look at just writing an equation given a graph. Okay, so just practice writing it. Again, this should be pretty easy. If we do number 1 together, or 1A, we're going to put it in slope-intercept form, and then we're going to draw them. Okay, so let's take a look here. I'll help you with putting them in. Let's say we have y equals, and then it's negative 1/2 x plus 3. 1b is y equals negative 3x minus 8. Here's where I would like for you to pause it, get some graph paper, throw these on a graph, and see what you get. Okay, go ahead and pause the video here and graph these two lines. All right, I'm going to walk you through what I'm going to do to graph them. Okay, so first we'll take a look at this one. I'm going to I put a point at 3 on the y-intercept. Okay, so there's that on the y-axis. Then the slope is negative 1/2, so I go down 1 and 2 to the right. I could also go up 1 and 2 to the left. Either way, it's the same line. Then I'm going to get a ruler or a straight edge. Lucky I've got this thing here to help me out. I'm going to make sure I use arrows because it is a line, so it goes forever in both directions, and there's my line. Okay. Again, and the arrows are important. Okay. We want to have the arrows so that it is. There we go. And then, all right, let's take a look at the second one. We have negative 8, so that's all the way down here. There's a y-intercept. And the slope is negative 3, so I got to go down 3 and over 1, but that's off the graph. So this is negative 3 over 1, which is the same as 3 over negative 1. So I could go up 3 and left 1. I always make 3 points just to make sure that my line is what I want it to be, really. So to make sure it's straight, okay? So there's my line. All right? And that's it. Okay, that's graphing lines. Let's see the points there. All right, let's take a look at the next one. When an equation is not written in slope-intercept form, a lot of times it's easier to put it in slope-intercept form before graphing. Now, this form we've worked with, this is standard form, and so we can find the intercepts and graph it like that. But we need to be able to change forms. We need to be able to go from one to the other. So we're going to take this and move things around until it looks like that. We do that using using algebra. We're going to solve for y. So we get y by itself. So we get all the x's on one side, and then we divide by whatever the coefficient of y is, and then we're going to graph. Okay? No problem. So let's take a look. Let's graph each equation. Let's change them to slope-intercept form first, right? So let's change them. So the first thing we would do on 2a, and here, let me get this on a new page. All right, so let's take a look at these two. We're going to move, remember, we're going to move things around and try and solve for y, so that then we can just use the slope and the y-intercept to graph. So here's what that looks like. We have, let's subtract 3x from both sides. All right, so I have negative 4y. That's a big mistake area right there. People forget that negative is attached to the 4y. And that equals, and I'm going to put the negative 3x first, because in the form y equals mx plus b, the x comes before the b. So negative 3x plus 12. Then I'm going to divide each term by negative 4. Okay, each term. I can't divide just parts. I've got to divide everything. So y equals A negative divided by a negative is a positive, and it's minus 3. So I'm going to go down here to minus 3. Hopefully this is what you did. Up 3 over 4. I'm going to do it one more time. There's that graph, and let's go ahead and throw a line on here. All right, and there's my line. Let's take a look at this one. Okay, so again, similar, 5y equals, I'm going to add 2x to both sides, and then I'm going to divide both sides by 5, and I get y equals 2/5 x plus 2. There's my y-intercept, up 2 over 5. And if I want 3 points, I can also go down 2 and left 5. And there is my line. Okay. All right. Except for the graph of y equals 0, which is on the x-axis, horizontal lines have a slope of 0. Okay. These are graphs of constant functions, which can be written in slope-intercept form as y equals 0x plus b, or essentially just y equals b, where b is any number. Constant functions do not cross the x-axis. Their domain is all real numbers, and their range is just whatever the y value is. We're not even going to graph these guys. This stuff is super simple. If we were to do, like, say, for example, 3a, you just go to the 5, okay? If it's y equals 5, I'm just going to go up here. I'm going to do it on this one. You just go up here to 5, and you put a line. On this one, you'd have to do a little bit of work first, where we'd have to get y by itself. So I divide by 2, divide by 2, and I get y equals 1/2. Well, 1/2 is really simply just in between the 0 and the 1, so I would put a line right there. No problem. Vertical lines have no slope, so equations of vertical lines cannot be written in slope-intercept form. All right? No problem. Let's take a look here. There are times when you'll need to write an equation when given a graph. So we got to look at the graph and get some information from it. So we look at this example, okay? The y-intercept is at 1, so I immediately know that's not an answer and that's not an answer. Then I'm looking for other clues. They're both negative and the line's going down, all right, so that's got it. But let's look at the slope. I go down 1 and then right 3. Down 1 is the rise, right 3 is the run, so I know the answer is C. All right, just it's as simple as that. Let's take a look at number 4. At number 4, first we have, what's the y-intercept? -1. So that's not an answer, and that's not an answer. Then let's count the slope. The slope is 1 over 4. So literally it's 1 over 4. So our answer is F. Really easy stuff, okay? We use modeling real-world data with a linear equation is done all the time, and almost all of you are going to have a job that does this. We use this in schools for everything from budgets to class sizes to all sorts of things, statistical analysis of grades to all sorts of things. So we have to be able to write a linear equation from some information. So write a linear equation to find the number of girls in high school sports after 1997, and here's all the information over here. So the equation is G equals 0.6 n plus 2, I'll erase this so you can see some of the numbers, plus 2.6. Okay, we know that because we started at 2.6 and it's increased by an average of 0.6 million per year, so that's the slope. So we graph the equation and we write the equation, and then we estimate the number of girls competing in 2017 just by plugging that in. Very simple stuff, okay? Here, let's do this. Throw this on a new page so you can see it. The Band Boosters are selling sandwiches for $5 each. They bought $11.60 in ingredients. Write an equation for the profit P made on N sandwiches. Graph the equation and find the total profit if 1,400 sandwiches are sold. Go ahead and pause the video right here. See if you can come up with one or any of these answers, and we'll check it in a second. Go ahead and pause the video now. All right, so let's take a look. First, write an equation for the profit P made on N sandwiches. So that's P equals, and it's $5 a sandwich, so 5 times N. And then they spent $11.60. Well, that's negative profit, so they're starting at negative $11.60. Okay, so that's A. B, graph the equation. Okay, so we really only need one side of the graph here. And whew, that's bad. So if this is 500 and that's 1,000, that's 1,500. Well, let's just do this. Let's just say each one of these is 250. So that's 750. So that's 1250. So it's somewhere in here. This is 1,000. So somewhere in here is 1160. And then, you know, we go up 5 over 1, up 5 over 1, up 5 over 1, up 5 over 1. So we end up with a graph. You can put those numbers in any way you want. It's probably easier to make a table here to graph this. So if we put in here's n and here's p. Say I don't want to use 1. It's too small. We're going to be doing this forever. So let's say we do 100. So we'll put 100 right here. If we do 100 sandwiches, this is negative 660. So that's somewhere in there. Say we do 200. Okay, well 200, that's negative 160. So that's somewhere, let's put this right there, that's 200. And so that's somewhere in there. And I've got my 3 points now, and that's enough to graph it. So my line's going to look something like that. Okay. Part C says, find the total profit if 1,400 sandwiches are sold. That's just, we're going to use the equation that we have. So P equals and we have this 5n. N is the number of sandwiches sold, so that's 1,400 minus 1160. 1,400 times 5, so that's 14 times 5, and 14 times 5 is 10 times 5 is 4 plus 5, so that's 7,000. Minus 1160 that we started with, so the profit there is 5,840 dollars. All right, that's it for the notes. I will see you next time, and we'll take questions and practice these. Try and get some graph paper, guys. It'll make things easier. See you. Bye.